Evening everyone. Let's carry on with a little bit more of zero-to-quake-3 project where we're trying to implement as much of Quake 3 as possible using a combination of Haskell and Vulkan, kind of doing everything from semi-first principles. Just to recap where we are, previous stream did a bunch of kind of correctness refactoring, got the depth buffer working correctly, and just tidied up some of the code. So it's all looking kind of nice for just the vertex color only pass, but the movement's quite jittery. Also, like if I'm going to hit W, and you'll see I'll kind of jolt forward, stop, and then suddenly start moving again. Excuse me. And that's just the kind of key repeat function stepping in, whereas we want kind of smoother input handling than that. Also, this is completely independent of time step at the moment, so if you run this on a computer that's better than my laptop, you're gonna absolutely fly around this map. And if you've got a computer that's worse than my laptop, it's going to be dog slow and take you a long time to move around. So we need to control for that, which is basically you do that by measuring the time elapsed between frames, and you scale all of your movements based on that, which is basically kind of Euler integration. So let's get a look at our input code. At the moment it's all living in quake3.hs as kind of like the entry point. Basically what's happening is we're reading an IRF and then stepping forward from that original state based on all of the input actions that happened, and then writing back an IRF, which is kind of okay, but I think functional reactive programming is a better abstraction for this kind of stuff. So let's see if we can introduce reactive-banana into this. Which is my FRP framework of choice. We still haven't set up the Cabal file kind of properly, or at least our Nix file, so let's just add it into this list for now. Pop it in here. Hopefully that's all going to build. While we're getting into that shell, so like the idea behind reactive-banana is you've got two kind of fundamental primitives, I suppose, or building blocks that you're going to build on. You've got behaviors, which are continuous time varying values that just vary over time. I think the model's got some nice diagrams of this, or maybe it's in combinators. We'll get both of those open. And you've also got events, which are discrete points of time where something happens. No, it's in the combinators, yeah. So here, a behavior, we can see values changing on the y-axis, and over time that value is changing continuously. Doesn't necessarily, let's think about this, I don't think it has to be a continuous function. It has to be defined at all points in time, but it can have arbitrary jumps, basically. And then the event here, you can see these stars are the time occurrences of an event. So to cast that into Quake 3 terms, like the location of a player is a behavior. At any point in time we can define where a player is, but things such as like shooting a rocket are going to be discrete events that then produce behaviors, because then a rocket's going to temporarily exist with a behavior. So where's that going to fit into our code? Let's have a look. So our model, probably our model. Maybe let's rip all of this. Kind of like, yeah, so I think we're going to have like, our model is something that you can give to the renderer, and it's going to be able to render out any particular instance of a model. Which I think is what we do at the moment. Let me just reorientate myself. So yeah, so render takes update from model. So we could keep that state, that's probably not too bad. So we just have to produce this state. So, how are we going to do that? have a quake-free network. When I looked into FRP frameworks, it seemed to be the case that signal transformers and not signals were preferred because of space leak issues. What are your thoughts? So there are, like, as far as I understand, there are kind of two ways of doing this. Signal functions were one way of doing it, where you end up in the arrow abstraction. And yeah, you think about signal transformers rather than the signals themselves. The other option is you can do it, and this is why I like reactive-banana, if you can kind of work directly with behaviors and events, but it requires a monad in some occurrences to kind of capture a point in time. So this monad, that's quite a tongue twister, is like a monad where all the binds happen at exactly the same time, conceptually. And that also lets you avoid space leaks with a little bit more complexity, because some things get sequenced into a monad. I'm not 100% geared up on the... I kind of want to call it theoretical, but space leak's not really a theoretical thing, like it does happen. I'm not clued up on that kind of operational side of it. But reactive-banana has been pretty good for me over the years, but I've only ever whipped together small things up in it, so let's see how far this one goes. So there's going to be some kind of network. Let's just start, actually, let's get start right at the top. Quake-free is something that varies over time. So it's a behavior of this quake-free state. Right. But let's keep that as well. So what's kind of cool is what we're going to give our renderer is actually just this entire behavior, and the renderer can choose when to sample it. Is kind of my thinking here. Maybe we can pull that off. There's no reactive-banana module. Is that true? There should be one. What's going on here? It's there. It's this bloody environment thing again. Does new configure produce one of these? No, so that's the problem. New configure doesn't entirely do what it says. Right, so so the renderer I think is kind of correct. I like what's happening here. It just takes, like, it's kind of a pure function in a sense that it, like, doesn't change the model or anything like that. So it's just quake-free that needs to, like, wire all of this stuff together. So what have we got at the moment? Forever frame with a state ref. Might break that out. Yeah, let's just do it in here. So there's kind of like two main parts to the reactive-banana API. You've got the kind of stuff that talks to the real world, which all lives in frameworks. So here we've got this like moment IO, and you've got the ability to have handlers, so it's add handler and stuff like that connect things in. And reactivate is the way to like produce events in the outside world. And then everything else lies in combinators, which is kind of nice and pure and independent of all of that stuff. One thing I haven't quite nailed with FRP is nicely desynchronizing rendering steps from physics time steps. Yeah. So I think we might have what you're suggesting, which is independent physics and rendering time steps. And it's kind of like captured in the fact that this renderer just takes like a model and renders it. It could do smarter things like diff between frames and do minimal recomputations of state changes and stuff. But fundamentally the idea is the same. Like, you just give it the state of the world and you say, give me this, like, show me this. and physics can go off and do its own thing and be a completely separate event. But we are going to need to interact with the real world to start with, so let's get this open here. Quake3.hs. So yeah, you generally build things in moment.io, which is like here. Heinrich's called it a network description. You then compile this down into a network, and then you actuate the network. But like this compile and actuate step, I've never really understood why you would need this network, so I just like bind these two in a monadic bind. So let's compile what should we call it? Rendered game, I guess. Feed that into actuate. The way that you can kind of think of reactive-banana as being like a callback based system, or it's like working with callbacks. So basically what happens when some outside event happens, you'll fire this special IO action that you have access to, and that will go ahead and progress this rendered game network forwards. But that actually means actuate just like it just terminates. It doesn't keep anything running. So we do need some kind of loop running somewhere. For that, let's just... So the way I usually do this is we'll have like some mutable variable, and then we're going to something like that. So what is going to happen in here is we'll collect all of our SDL events. Yeah, that's probably all we really need to do. We also are going to have to, we'll put in a clock step, but let's leave that out for a second. Yeah, I'm going to try and not think too hard on this and just see what we end up with as an output. So we're going to need some input output. So yeah, you have these add handlers, which are the primary way to push things into the network. So you can either have from add handler, which takes an add handler and gives you an event, which means whenever you like push something into the add handler, an event happens in the network. Or we've got from changes, which is kind of like whenever some other event happens, this one's going to get polled. Is that true? No, from polls that, sorry. Yeah, so add handlers just represent discrete events, yeah. And poll means you can do an IO action whenever an event happens, but I never really find myself using that one. So we're going to need a, what is an add handler? We're actually just going to have a handler. Let's call this on events, which is a handler for a list of SDL events. to return a network description. Can I do that? Yeah, I think I can. So we have to make some of these add handlers, and that is done by calling new add handler, which gives you the add handler itself and this handler, which is a function that's basically an I/O computation that you push things into. So we are going to have event let's do it that way. So with that I can return the output, and also maybe this is just quake-free model quake-free. Return quake, well, pure quake-free, because it doesn't need access to moment I/O. So this is also going to have access to the output. So that's going to fire on events with events, and then it's going to tick again. Right, so yeah, that will need lifting. This maybe we can like that. So we don't have rendered game, so yep, so that's I/O and game. That means just some I/O. Yeah, that looks reasonable. So a game is actually a compilation of a network. Yeah, it shouldn't really return it, I think. So yeah, Quake-free model Quake-free gives you back a model at any point in time, so we need to do something with that. So in frame, what we did was update from model, and we had to do all of this stuff. We need a way to like push that out as an output. Can stick it in here. I'm not happy putting this inside this pure block. Feels like the wrong place to put this code, but we can move that out later. So that is a behavior, and what you can do with behaviors is we could step them to see whenever they change. Don't really want to do that. Let's have an event on render for now with no payload. So that, yeah. So let's see, what we want to do is whenever on render happens, take a snapshot of Quake-3, basically. What am I looking for? So, sorry, that's reactivate. So reactivate, as it interacts with the outside world, it lives in the frameworks module, and reactivate takes an event that is I/O and just basically does it. So we don't have an event at the moment. Events are just functors. That's okay. So what we'll do, the way I do this is use this backwards fmap type combinator. And now in this here we're just in I/O. So that doesn't. If we're in I/O, we don't have access to this Quake-3 behavior. So what we need to do is snapshot it using the event. So you'll see here. Let's scroll through it. There is. This guy, which is kind of handy. So it's a bit like that operator that replaces a functor with like every occurrence of a value in a functor with a constant value. This replaces every occurrence of an event with that behavior at the time the event happens, which is exactly what we want. So we can replace the unit of on render, Quake-3 model Quake-3. And then we can map that into a rendering. But that we actually need render.hs, which takes, what was it, update from model, takes resources and a Quake-3 state. We actually probably don't need that combinator then. Update from model. And then we need to reactivate all of that. So yeah, this you can read as like sampling Quake-3 whenever a render happens to produce a model, and then we can just give that to Quake-3 render update from model. That is no longer pure because we're interacting with the outside world. And yeah, so we have resources, so let's pass those into the game. So on render is a handler. We actually need an event, so we can form that. Again, we go into frameworks. We can turn an add handler into an event with from add handler. So one thing I do struggle with here actually is just naming these things. So you're basically going to end up with an add handler, a handler, and an event, and I can never really work out what we want to call them. So maybe this should be. I kind of like calling reactive-banana events like on to emphasize the fact that they're like a point in time on this event happening, like this point in time happening. So maybe we'll call the events on render, their add handlers just have the add handler suffix and the handlers have the handler suffix. So tick, what are you complaining about? Okay, so it's all good, but I mean, it's going to be tricky that we won't be able to see anything because we don't have any input interaction at all. That immediately terminates. Oh no, I did new build. Yeah, new run just doesn't present or anything. So add handlers give us a way to push things in, reactivate gives us a way to push things out. You know what, one thing we could do there's a couple of ways you could do this. Like we could use some kind of like STM variable that you could write into. That might be a reasonable way of doing it. I think we'll stick with this. Because yeah, so like to think of this as a callback system as well. Like basically what's happening is like when we call this on events handler, it basically like does like a non-local jump essentially into this network. We're not actually using on events at all in here, but if we were, the event would suddenly fire, any reactivates would happen, and once everything's finished, we'll carry on with normal code. So that's basically the same as what's going on down here. So previously we were calling update from model with this S1, so we can call essentially update from model by making this event happen. So there you can see there's the update from model. So we will just call on render handler with no extra information and then just do all of this. So acquire next image. This needs access to context, I think. There we go. No. That's the one. Command buffers, I think, are part of the resources, which are also not passing in. This stuff may well, you know, I can see this all changing at some point as well. Exactly what gets passed around where. Why did we need that again? Oh yeah, for those command. Oh, so the command buffers are here. Oh, that's annoying. And they are also doing it over here. Ah, where am I? Yeah, right. So that's actually not that. It's a Vulcan VK. Okay. Hiya, welcome to the stream. I'm glad to hear I'm not muted. It would have been a slight waste of time. Okay, so we're back to having just that blue screen, and if we can figure out what the correct angle is, we should be able to see the world still by just updating our initial state. What is, I mean, these are measured in pixels. Yeah, okay, so we can't interact with it, but it is there, and we can see that the rendering's all still working. So yeah, now let's look at doing something more interesting with this. So we still have this input thing, which is quite nice, but now what I can do, yeah, let's have a look at this. So this event to action lets me take an STL event and turn it into a QuakeFreeze model action. I'm going to keep that. But what I'm going to do is this is going to now have an event which is an action. Okay. Means Quake3 has to be changed because right, so yeah, we definitely don't want that anymore. We're gonna have to break this out. Let's call that model. Quake3 model Quake3, and that now needs that on action thing. We don't have access to that, but what we do have is we can make on SDL events. From add handler on events handler add handler. Let's see now. Right, yeah, this is still not a melodic value, so that way. So we've got a hole here that takes an event containing multiple SDL events and should actually be an event containing a Quake3 model action. That's fine. That is just fmap fold? No, fold map Quake3 input, what do we call it, from event? Event to action. That's arguably going to be nicer. I'm not a huge fan of the applicative operators. That definitely tidies things up. Cool, so we're not using that, so there's not really much point running this. Let's get rid of this documentation. Go back to our models, right? So we're not using on action. So what do we want to do with that? Well, that is exactly what was happening in this step type thing, except we don't have. We're not going to be given the previous state. So we need to somehow keep track of that. I'm doing well today, thank you. Hope you're doing well as well. If you're just joining us, we're refining our game logic loop by moving it over to functional reactive programming today. So this is going to be state is going to basically be a fold over all of these event actions from our initial state. So full screen up. So we have some accumulating operators. So accum B takes some A and like an updating event and gives you back a behaviour of those A's, which is exactly what we're looking for. So we're calling it a model. Let's call it a model. And there's not really much point binding it because we're just going to return it. So quake-3 is simply the accumulation from our initial state using step on action. To get that to happen, I'm going to have to just switch those around. And this now becomes monadic because accum B occurs in moment because it basically has to start from a distinct point in time. Okay, now quake-3 is complaining. Because this is monadic now. We just need to bind that in. And we're not going to do any of this anymore, so we'll go. We should be back to where we were now. Voila. But that hasn't really solved any of our problems because, as you can see, we've still got the jitteriness. So that's no good. But what we can start to do is refine what's happening in this model now. So what do we need to do? I guess one thing, we'll probably end up merging this step function into this. So let's anticipate that and just move it underneath. So we can think of a couple of things that are like things we want to hold at points in time. So like velocity would be one of them. So when W is down, your velocity is set, and when you release W, your velocity is released. So maybe we could just like holding. Does holding an action work? Probably. But we'll have to change what action is. Action's not a great name, but let's keep it for now. See if we can come up with a better name later. So our SDL events are going to map to things like an is running bool or something like that. You have to keep track of key presses. So you start keeping track on key press down and then you remove on key release. Yeah, exactly. So, but it's just exactly what I call those things. It's a slightly tricky thing. So I'm going to keep it as action for now, but I'm not entirely happy about that. And basically what's going to happen is when you press W, that is an action that means is running as true. And when you release W, that's an action of is running false. And then basically what we can do is we can just kind of flatten that or smear that action out to be defined at all points in time to just simply hold on to values and use a stepwise function whenever they switch. Or maybe it's like, it's kind of player state, I suppose, isn't it? We'll go with this running forward for now. Take this. In fact, let's drop all of that step for now. So we've got this on action thing. I'm actually going to turn that into I want to call it is running forward again. But we want to think of these as events, so maybe on. I don't know, something like that. It's not a great name, but so on. So running forward now becomes. I think it's just a stepper, right? So we begin not running forward, and that changes whenever on action happens, and we'll take whatever on running forward changes from an action. That now means that we could integrate that over time to find our position, which is something we're going to have to return. So let's say camera position. Maybe because behaviors represent things at all points in time, maybe there should be kind of plurals, like camera positions is essentially a stream of all positions. I think it makes sense to separate it into two stages. One, keys currently pressed down, two, directional movement, and convert from 1 and 2 using full map, and the monoid instance for directions. Yeah. The problem is there though. As long as we did that inside the FRP framework will be okay, but if I do it outside the FRP framework, I won't be able to easily know that. Will I? I'm just wondering if I'd be able to know that a key was released or that a key was kind of never pressed, because they're both zero vectors. Let's stick with this for now. We can refactor afterwards. Let's see what we end up with. I'm going to just kind of keep thinking out loud as I work through this one. So camera positions is the accumulation of. So I now need some kind of time step to integrate over. So I'm going to begin at the point 0, 0, 0, 0, 0, blah blah blah, whatever. And whenever we get a physics time step, I'm going to progress running forward. I'm going to progress forwards along the direction I'm facing, which for now could just be adding all. Any, that's the one. Expected. Yeah. So I didn't want to apply that. I wanted to replace the event with that for now. First, okay, so that's got to be pure. Oh, so actually that is the operator I wanted. So now we just turn. I'm going to use applicative do there. Although, what I could do, I guess I could just use yeah, I can put impulse in here. Oh, so I want to rotate it, wasn't I? Replacing impulse with that. So this keyboard action, I'm going to change, just keep that. So if you press W, otherwise T, and that now becomes true. So Quake-3 now needs the action event, but also a physics time step event. So let's set one of those up as well. Yep, so that takes the amount of time that's elapsed. Let's just tick that forward to like 1/100th of a second or something like that. These are fixed time step for now. So just after our events have been handled, this is all going to change, by the way. Exactly when we call these events isn't necessarily going to be in this fixed order that we've got. So, shouldn't you have a behavior which keeps track of all inputs so you can access that whenever you want? And in this particular case, you write a function that takes this input behavior and converts it to a directional behavior. Where are we going? That's kind of what we've got with running forward. Like that is running forward is a behavior that captures whether or not we're moving forward, and we're going to turn that into our like wish there, as it is called in Quake 3 terminology. But why are we constantly? Oh, right, okay. That's to be expected. Sorry, because yeah, whenever our physics time step happens, we're moving exactly 1 unit per second along the positive z-axis. There seems to be some recent discussion on reflex supporting dynamic, which combines behavior and event. As I've never used any of the Haskell FRP libraries, I'm not sure how useful that would be in anything. So it's understandable why they came up with that abstraction. Like all it does is pair up a behavior with its event, so you can kind of unpack it and see its underlying changes. I think in some work code where we use reactive-banana, we've kind of invented the same thing. But the nice thing is, like, it's a derived, it's something derived from the core system. Like, it's not fundamental to FRP. It just, I suppose, if you bless it as a primitive, you might be able to do it slightly more efficiently. But it's not essential to the theory, which is quite nice. So if we need it, we can invent it. Basically, that's kind of what I'm saying there. So, with your on physics step, we're going to go forward 1 unit, but that's not what we want to do. What we need is our kind of velocity. So our velocity is simply a function of are we running forwards or not for now. So we're going to take effects pure. For now. We can have more complicated velocity calculation functions later. And this is now going to add velocity to on physics step. That now has to be the apply operator. And let's get that reverse fmap operator in scope. Oh, really? Well, lens does. Cool. So yeah, now velocity maps over are we running forwards or not, and turns that into an interpretation. Which is quite nice, because before, our input layer, which was kind of mapping from keyboard interactions, was mapping keyboard interactions into actual kind of like gameplay specific things, like how far should you be moving forward, which is questionable. Like I don't think the input layer is necessarily in charge of knowing about that. Kind of surprised why we can't see anything, because when we set this initial state we could see our model. So have I broken something there, or are we not? We're not using that anymore, are we? Right, so yeah, let's just change this a second. No. What do I got to return? Yeah, it is camera angles, okay. Okay, so now, interesting, like we've still got the same problem. Not entirely sure why that is though. That would suggest that we're seeing okay, so I think what I want actually is not There are a few interesting ways we could slice this. We'll do it with a maybe for now. I might revisit this afterwards. So that's that. So basically what's happening is other events are happening when we're holding the W key down, but they're getting mapped into an action, which is correct. But that action is using mempty here, and the mempty instance for any is false. So it basically goes true and then just immediately gets reset to false again, but we're stepping over all of those. But what I really want to say is there are SDL events that can't say whether or not they change are you running forward or not. So we'll use maybe to kind of punch a hole in things there and say, actually, you know what, I don't want you to even worry about this. This maybe has a monoid instance actually. I probably don't need to use that any as well. Let me just quickly digress onto that. Maybe needs A to be a monoid, yeah. There's last and first, not really what I want. And option would require it to be a semi-group, which, yeah, okay. So we'll stick with maybe, just get that deriving. And now, what's kind of useful here is there is a filter function. Filter E. Before there was one, yeah, filter just, sorry. So that takes a stream of maybes and gives you back the things that are just, which is what we want. So we're going to take on running change. We're going to filter out for just the ones that change whether or not we're running forwards. And then we're going to run get any on that. That's the one. So that's now just any true. Horrible new types. So this now, if I've got this correct, it is actually only going to let us begin moving forwards and then we'll never stop. Because nothing ever sets it to just false. Okay, well, we'll move backwards. So it's the same idea. So I'm not pressing anything now and we're just flying through space. But we are doing it smoothly, which means we're on the right track. So, that's problematic. I can't can't hit Control C. Where's my mouse gone? There we go. We should probably put a quit button in at some point soon. So basically what's happening is, yeah, like we're looking at key press events here. What we actually care about is that is like a toggle down here. So running forward change is true if the keyboard motion is a press, and if it's not a press then we're going to stop running forward. So now that should, he says, writing invalid Haskell syntax. Yep, don't need that anymore. In fact, we can tidy this up by kind of folding this into a Boolean equality check as well. There we go. That's nice and smooth. So yeah, let's tidy that up. So, is that true? No, no, that's how I want to do it. The problem is, like, we change whether it's nothing or just. Might be clearer to say nothing or just there. The other option is action stops being a product of things and changes over to something like start running, stop running, start strafing, or something like that. That would kind of add the restriction that one SDL event maps to exactly one action. We could have a list of actions. That would also work. And then the way I'd process this is to have Quake-3 still take event action and just process it one by one. I wonder if that might come out nicer. Let's explore it. So some events now, SDL events won't even be able to. Oh, okay, we're gonna. Yeah, we'll do it 0-1. Some events won't even map to Quake-3 actions. These are maybe as well. Oh yeah, we're not going to have this monoid anymore. So we're going to kind of like expose some pattern matches as functions. We could use prisms, could use generic lens. Actually, how does this look with generic lens? I've never explored that. Oh wow, that's cool. No, I guess that won't work because that's going to be. That must be the typed one. No? How does this magic work? Okay, I missed the. That's cool. Yeah, this looks nice. Let's give this a shot. Why not? Let's try and do something fun. If you haven't seen this library, by the way, it's absolutely killer. I've only used it with generic products. It's so cool. So we've got on action. We need to basically preview that through one of these. So let's preview it as. Apparently, I can just do like toggle run forward. So we look at an action and see if we can preview it as a toggle run forward constructor. If we can, that's going to give us the boolean inside it, which we can then just pass the stepper and we have running forward. In theory, if I got that right. I do need type applications. Okay, that makes sense. Yeah, okay, that kind of makes sense. Preview from lens. Hmm. Could not deduce as any. Let's try it with the symbol. I'm not driving generic. That'll be why. This is maybe. So let's do push this pattern matching up to the top. So if it's W, then this is just a toggle run forward. Take that open A. Perhaps you meant, yep, I did, Quake-3 model. No monoid instance. It looks like it all type checks. He says, optimistically, and it doesn't. Right, so we can't do this fold map anymore. So let's see. We have a couple of options. I don't think there's. I mean, there are ways that we could turn one event of a list into a list of events, but there isn't a distribute operator, I don't think. Yeah. I think the better option is to pass in. Well, we're already doing this event to action in this module anyway, so let's just do it up here. So this is Quake-3 model action. So you are now on event. Well, actually, actions. Action. There we go. On action handler. On action. Quake-3 doesn't need. On event doesn't exist anymore. So we're going to have to traverse. Lift eye on the outside. On action handler. Events, we're going to do Quake-3 input, I keep forgetting what this is called, event to action. But that could be nothing, so we'll traverse over that again. Cool. So yeah, that's kind of nice. I'd like to do it without a string, which I don't know why that doesn't work. Maybe I'm on an old version of this. Go right into my shell. I'm on generic. Oh my gosh, 0.5 miles behind. Let's have a quick look at the changelog and see if we're missing anything too important there. Prisms are now optimal. Monomorphic versions of lenses and prisms also included. Don't know if that's it. And okay, we won't drastically add. We'll leave it for now. We'll leave it as a string. Because we've been at this for a while, it'd probably be good to start converging on parity to what we used to have. So let's just double check this all still works. Inexhaustive pattern matches. Better not press any other keys. And let's just quit by crashing the program. So that's quite easy to fix. It just means if you press anything else, we're not going to handle that for now. Let's get the mouse motion back in. That's not too hard, so we can just drop in a turn by action, which was what, a V2 events? Oh, I see. I can see it above. So I think we could do everything maybe with this orientation. No, what we were folding is camera angles, isn't it? So let's just fold those together. So it's initially 0, 0, and then actually, no, I want the turn event, don't I? So let's say on event, on turn, is filter just preview as turn by. So we get all the turn events out of actions. That is an event. So I need to subtract I think. wire this in. Yep. That was easy. But of course, we've got the problem that our W press doesn't take that into account. But that's okay because we can just say orientation takes camera angles, splits them into X and Y components. So that's a behavior. So then we've got forward vectors, which are simply the rotation of I guess it's not really a forward. Let's see. So yeah, we just want to like rotate that thing. Yeah, so right, so that should be okay. So I want to yeah. Look at that, smooth camera. Seems to be doing the right thing. Could be a little bit faster, but I'll do the job for now. We can't move backwards or anything, so we still need to implement all the other controls, but that lays the foundations now for building this in a functional reactive framework. If anybody knows more about quaternions, I'd be curious if we could store a quaternion rather than storing camera angles. Let's have a play with that. If anybody knows that this is definitely not going to work, let me know. The reason I ask is it would be quite nice if our model or our state had camera orientation, because in the render pass or render function, we're recomputing the orientation. So not only have we got code duplication, we've got like work duplicated as well. So I think we can just like accumulate an orientation. Probably don't want the zero quaternion. Drop the GHCI here. So we're normally doing axis angle V3 0 1 0 0 times axis angle 0. How do I make that? Got the identity quaternion. We'll probably run into roll issues. Yeah, that was kind of what I was thinking. We might end up rolling the camera. Mate, so I suppose rather than accumulating quaternions, why don't we just store the orientation? And then at least we can reuse that. At the end of the day, you do want those two angles, which are the Euler angles of the camera. Yeah, certainly. The other way to accumulate quaternions is to keep multiplying them instead of adding those two angles. But if you keep multiplying, you'll run into roll. Yeah. So I think you're saying that you're probably on board with this type of representation, just keeping the Euler angles in there. I'm inclined to do that. As long as I didn't misunderstand you. Really need to finish my intuition with quaternions. So, what are you complaining about? Do we need? I don't think we need initial anymore. I'm actually kind of happy calling this action as well. It's a bit like kind of CVARs. So I think I certainly remember from Counter-Strike, which is obviously a Quake engine, it's like C forward +1 is what happened when you held a key down, and it went to 0 when you released a key and stuff. It's kind of like this action thing. Okay, that's all good. Let's tidy some of this up. So model doesn't need monoid. Let's drive monoid. I haven't made use of that new data yet. Where am I? X and Y. Doesn't need linear as well, which also sounds nice. So I kind of like the responsibilities of this module now. I'm going to leave strafing out. We'll come back and re-implement that. We're obviously going to know we're missing it. That'd be nice with lambda case. Oh, no, I can't do lambda case, can I? And got some final things to tidy up in Quake 3. Okay, so I have yeah, so Sam said that the way to think about quaternions is the basis quaternions are infinitesimal generators for rotations around the respective axis. That bit I'm kind of okay with. I think maybe it's less the quaternion side of things and more the interaction with going from quaternions to like actually like a concrete application and the strange behaviour that you get probably by the fact that three-dimensional rotations aren't commutative, that you can end up with situations like gimbal lock and things like that. That's more probably the bit that I want to iron out. Oh, we do use lambda casing, that's good. Okay, so I think I'm going to wrap up there. I haven't really. We smoothed the input out, which is quite nice. We don't have a fixed time step, which I think while we're in this area might be the next thing to look at, which basically means we're close to it. Sort of. We have this fixed physics time step of 1/100th of a second, but we're applying that with no respect to how much time has actually passed. So we need to basically just measure the time between each frame, or each time we call the physics update, and progress physics by that fixed time step as many times as would fit into the amount of time that's elapsed. So for example, if 0.02 seconds has elapsed, you'd run this twice to catch up with the current time. And we'll probably be able to break all of these out into like some separate things, maybe even separate threads would be kind of cool. But like rendering just wants to happen as fast as it possibly can, the event loop wants to happen as fast as it possibly can, and the physics loop wants to happen progressing along this fixed time step, essentially. So we could do that with threads. That might work, but I think we'll look at that on the next stream. So let's just get this updated plan. I'm going to just tick off better input handling. It's not strictly what we've done, but that's kind of what I meant by that point, was to get like a proper FRP system in place. So yeah, next week we will look at fix your ankles, no, fix your time step. Really nice article. Oh, it's changed this blog ever so slightly, I think. That goes into a bunch of different options. Free the physics is kind of where we want to get to here. So I will refresh myself on that one, get us ready for that, and yeah, we'll crack on with this a bit more. And it'll probably again be tomorrow evening. Think I'll be streaming then. So normal announcements. If you want to follow along, obviously I'm ocharles_ on Twitch, but you know that because you're here. I'm at Acid2 on Twitter. And I also have a YouTube account where all these videos are getting uploaded to, so you can subscribe to that. You can follow me on Twitter to get the go live announcements. Whatever, you're all here, so you figured it out somehow. So I will catch you on the next stream, hopefully tomorrow. See you then.